Okay folks, in this lesson we take a look at other Arnold render settings that we haven't discussed yet. So let's open up the render settings windows and go to the Arnold render section. If you open up the sampling section, we have a few other options other than the different samples. Lock sampling pattern locks the anti-aliasing seed for each frame, so the sampling noise would be the same for each frame. We have indirect specular blur, which sets the indirect specular blurring to reduce caustic noise. Setting it to 0 gives the most accurate but also noisy renders, while higher values blur caustics to reduce noise. I think when we were talking about caustics in our standard surface shader lessons, I made a mistake, and this is actually the parameter that you need to increase if you had some caustic noise. Then we have clamp sample values, which allows you to clamp pixel samples to certain maximum values that you define down here in the AA sample clamp and indirect sample clamp parameters. And the clamping is especially useful when you have fireflies in your scene. Fireflies are when you have very bright pixels here and there in your render due to a very bright HDR image, or when you are dealing with volumetrics or any other reason. Indirect sample clamp specifically is the threshold to clamp away fireflies from indirect light samples and reduce noise. This works similar to AA sample clamp but preserves specular highlights from direct lighting. Lower values result in more aggressive noise reduction and possibly at the expense of dynamic range, so you're gonna lose some dynamic range when you are obviously clamping. Here using clamp values, obviously you can say that no pixel, for example, should have a value brighter than 0.5. Okay, you can see now we are clamping any pixel that is brighter than 0.5 in the IPR. You have affect AOVs, whether clamping is going to affect different AOVs or not. Let me just disable clamping for now. And we have different filtering algorithms for sampling process. It's a long list here. Basically, a filter averages individual subpixels into a final pixel color, and Solid Angle recommends using Gaussian or Black-Harris filter. You have a filter width. By increasing it, you're going to get softer and blurrier result, but you should see less aliasing issues. At the same time, increasing it would cause the loss of detail. If you want a sharper final render, you can decrease this value, but 2 would be a great number to use with the Gaussian filter type. We talked about ray depth, environment, and motion blur sections. We talk about texture settings in the next lesson separately. Then we have this color manager section. A color manager is a connection between Arnold and an external color management library like OpenColor.io or SceneColor. Color manager hold information about the availability of different color spaces and also transform RGB colors to and from the rendering color space. We have the built-in color manager, which knows about 2 color spaces, sRGB or linear, or you can choose OpenColor.io color manager, which is a complete color management solution geared toward motion picture production with an emphasis on visual effects and computer animation. And now you can modify this color manager using these new revealed options. You can read more about this section in the Arnold support page. It's a bit advanced. For now, let's set the color manager to built-in. Then we have this advanced section. First, we have this use auto bump in SSS, and if enabled, it allows the displacement auto bump to affect subsurface scattering and therefore capturing more detail, and also it is going to increase your render time. Low light threshold. Here you can tell Arnold if the amount of light contribution is smaller than this threshold value, don't calculate that light any further. Let's in this case get out of the camera and change the perspective view a bit. Let me disable all the lights in my scene except for the first one in the list. Now if I increase the low light threshold to 0.7, you can see immediately we get this line separating brightness and darkness. So basically in this case, when the amount of light contribution is smaller than 0.7, Arnold stops calculating it. Let me enable all the lights and reset low light threshold to its default value and get back to the camera. we have subdiv dicing camera, the camera to use when determining subdivision levels during adaptive subdivision. If you remember when we were discussing subdivision and displacement mapping, I explained that we can introduce adaptivity to our subdivision by increasing the pixel error value. So if you have a camera in your scene, you can specify that camera here, and this way that camera will be used during subdivision calculation for adaptive subdivision. So basically, when you have adaptive subdivision going on, by increasing your pixel error value to more than 0 in order to avoid flickering to a certain extent introduced by motion of the camera, you can specify that camera in the dicing camera parameter, and that way hopefully avoid flickering. We have AOV shaders list, which is a list of shaders that will be evaluated after the regular surface shader. With this, it's possible to add shaders to set specific AOVs without modifying the original shader strip. An atmosphere or background shader is set. These global AOV shaders will also be run for atmosphere and background contexts. It is useful, for instance, in the Cryptomatte workflow. We have system tab with some useful settings. We have bucket scanning, which is the spatial orders for the rendering buckets. By default, we have spiral. That's why when I render my scene to the picture viewer, you can see the buckets are rendering the image in this spatial fashion from the center of the image. Then we have top, left, random, spiral, and Hilbert. So if I set it to random and render my scene, you can see the buckets start randomly in different places. It's totally your choice. So let's set it to default spiral mode. We have the bucket size, which is quite self-explanatory. So if I change it to something like 16 and render my scene, you can see the buckets are much smaller compared to the previous one. Bigger buckets generally are going to give you quicker funnel renders, but smaller buckets are going to give faster initial feedback. Let me stop the render and set the bucket size to the default of 64 pixels. We have display bucket corners. If enabled, you can see the buckets being rendered are highlighted in both picture viewer and IPR, like what we saw in our render. You can disable it only in the IPR. So the corners will only show in the picture viewer and not in the IPR, or disable it completely for both picture viewer and for the IPR. Then we have auto detect threads, which allows Arnold to detect the number of cores and threads of your CPU. You can disable this value and specify the number of threads you want Arnold to use manually in case you wanted to limit Arnold to use all your machine resources. Let's enable auto detect for now. We have export scale, which defines the mapping between Cinema 4D and Arnold units. A radius of a default sphere in Cinema 4D is 100 centimeters, whereas in Arnold it is 1 unit. So a 0.01 scaling is used by default. If you work with smaller objects, for example with dimensions around 1 centimeters, you must use a higher export scale value like 0.1 for example, or 1. This parameter affects all meter unit values, vertices, camera and light position, displacement height, bump height, etc. Then we have this IPR setting. So if I enable my IPR, you can see we have this progressive refinement. The image is rendered several times, and each time AA samples will increase to give us a cleaner result. If I disable progressive refinement, we disable this function and the IPR will render the scene like picture viewer, which is not a good idea, and it's the opposite of what IPR is for. We need that fast initial response when we change a setting in our scene, and disabling progressive refinement would defeat the purpose. Let's enable it again, and we have this initial sampling level, which is the initial AA samples used for the first progressive render in the IPR. So the more you decrease this value, the faster the initial response would be, but it would be also block here. So if I set this value to say something like -6, as you can see how fast the initial response is, but quite blocky at the beginning. Let's set it back to -3. Also, you can enable custom bucket size and define IPR bucket size separately from picture viewer bucket size. Down here you have a few search paths. Basically you can define where Arnold should look for your procedurals, plugins and textures. After that you have some simple licensing options, and when I say plugin in this search section, I mean third-party shader libraries, custom procedurals, or volume binaries or stuff like that. We discussed AOVs. We have diagnostics tab. Here you can find out where you have problems in your render and debug those problems, and also enable or disable certain features. Arnold generates a log if you wanted to report rendering steps and any warnings and errors. By default, you can see it is saved to Cinema 4D's console, but if you want to, you can disable console and enable file and save that log file wherever you want. Let's disable file and enable console. We have verbosity levels, which specifies how detailed the log messages should be. So when set to errors, the log would only contain errors. If set to warnings, both errors and warnings messages will show up. If set to info, you are going to get errors, warnings, and different information and statistics. And if set to debug, it will show everything and might increase your render time. We have max warning, which limit the number of warning messages to the number defined here. Abort on error will stop the render as soon as Arnold detects an error. If abort on render is disabled, texture errors will show in red in your render, and NaN errors, which is when a shader returns a number that is not an integer or an RGB value, will show in blue. Next we have user options, and this field allows you to access and set Arnold core parameters that are not currently exposed in the C42A user interface. It's a bit technical and you can read more about it in the Arnold support page. Then we have future overrides. As you can see, you have some options and switches which allows you to disable or ignore some of the rendering features. So let's run IPR. I can, for example, ignore all the textures in my scene, or ignore all the shaders. I can disable all the lights in the scene, or ignore shadows, ignore subdivision, motion blur, or depth of field, and so many other things. And this future override section is extremely useful, and it allows you to quickly ignore these important features. Imagine you're done with texturing and now you want to do some lighting. You can ignore textures and this way have a faster feedback while lighting and so on. Also here we have this shader override, which allows you to override the shader for all objects in the scene. So if I define this simple white standard surface shader as my shader override, you can see it will override all the shaders in the scene temporarily. And if I clean this shader override or clear it out, we are back to where we were. Maximum subdivision sets an upper limit to the number of subdivision iterations for all objects, which you can refer back to subdivision and displacement lesson of this course to get more information about subdivisions. 255 is very huge and doesn't affect the scene, but if you use lower values like 2, 4, 6, it's going to affect and limit your subdivision iterations. So in this lesson we discuss different rendering settings. In the next lesson we take a look at the TX Manager and texture settings. So see you there.